Okay, gentlemen, we're going to start off with learning the law of cosines, or the cosine law. This is the last formula that you're going to really have to memorize for the rest of the year. So good news, we finally made it. We want to take a look at the cosine law. I've written it three different ways here, right? Remember that uppercase letters are the vertices and lowercase letters are the corresponding side lengths. But look at this. It's really the Pythagorean theorem, right? If I highlight this, this is really c squared equal a squared plus b squared. But then we have this portion at the end, this minus 2ab cos c. So the one way I like to describe it is the Pythagorean theorem with an adjustment, okay? It's because we're not necessarily dealing with right triangles, but the Pythagorean theorem does deal with right triangles. So taking a look at that, this minus 2ab, notice that there's a link. If I have an a squared there, an a comes there. If I have a b squared, then I'm dealing with b. So because I have an a and b here, we have an a and b here. And if we're talking about c squared equaling something, then we're relating it to its corresponding side angle c. Same thing will happen in another version, right? If I want to start off with, let's look at this version right here. If I want to start off with b squared, then I have the other two letters, a squared and c squared. Well, because I have a and c there, I'm going to have an a here and an a here. Oh, sorry, because I have a and c here, I have ac here, and b links with its angle, cos b. If I write it as a squared equal b squared plus c squared, then because I have b squared and c squared here, I have minus 2bc, and a squared links with its corresponding angle cos a. You really don't need to memorize all three formulas. Really, I would just memorize this one right here, because it's the most familiar, like the Pythagorean theorem. And we will at one point have to rearrange that formula. And I'll explain that in a little bit. But let's just take this formula the way it is right now. We're trying to find the length of an indicated side length in triangle DEF to the nearest tenth of a unit. Well, we just learned the sine law. And when I look here, I have an angle. I don't know its corresponding side length. I have a side length. I don't know its corresponding angle. Have another side length, and I don't know its corresponding angle, which is not good, because the sine law says we have to have at least one corresponding angle and side length. And because I don't have that, I have side, angle, and then side, and none of these correspond, then I'm going to have to use something else. And that's really the cosine law. So I just told you to think of c squared equal a squared plus b squared, and then minus 2ab cos c. But we're not dealing with A, B, and C. We're dealing with D, E, and F. Well, that's fine. We're just going to switch the letters around. Remember, we're looking for D. So I'm going to write this as D squared equal, and the other two letters are E and F. So I'll write E squared plus F squared minus 2EF cos of D, because those correspond. So now we're going to try and solve for D. We already have some other information. D squared is going to equal E squared, which is really 11 squared, plus F squared, which is, oh, I wrote that a little silly, 11 squared plus 14 squared minus 2 times 11 times 14, and then cos 82, because we know the corresponding angle. Here is really GDC work. If you can, use your graphing display calculator and figure what that comes out to. I've got the luxury of having done it already. So D squared equal this whole part here, if you type in your calculator properly, will come out to 274.13. And then if we want to find D, we're going to square root both sides, and we're going to get D equal approximately 16.6 centimeters. I'll put a dot over that because we're using an approximate answer. And it's that simple. Okay. This question, Kara is standing in the center of a field at point C. From where she's standing, she can see 4 posts at different positions on the field. So she sees A, B, E, and D for those four posts. And this question asks us, can she determine how far apart posts A and B are? Well, okay, if we want to find how far apart posts A and B are, we're really looking for that side length. I'm going to call it X for now. If I'm looking for X, how will I find that side length? Well, if I look at this triangle alone right here, I have a corresponding angle and side length. That's looking a lot like the sine law. The problem is the side length I don't know, right, does not have a corresponding angle. If we knew what the angle right in here was, we can then use the sine law. but we cannot yet. So how do I go about using what we know to be able to help me? Well, if I knew that angle, I'd be good. So I look at this triangle here because I know opposite angles are equal. Opposite angles are equal. If I know this angle in here, then it would be equal to the opposite angle, but I don't know that either. And in this triangle, I only have 3 side lengths. This is where the sine law comes in handy. The cosine law, or the law of cosines, comes in handy. Here we learned that when you have side, angle, and side, like they call it the cosine sandwich, right? You've got those 3 in a row like that. That's a perfect telltale sign. You're going to be using the cosine law. Here we have side, side, and side. We only know the 3 sides. That's also another telltale sign. You're going to be using the cosine law. Okay. So let's start with the cosine law here. But this time, gentlemen, the big difference is we're not looking for an angle. So before we would write, again, we're using letters C, D, and E here. So if I have C squared equal A squared, oh, sorry, we're not using A, apologize. C squared equal D squared plus E squared minus 2DE cos C. That's really what we're looking at. But we're not looking for a side length C anymore. We're actually looking for cos C, or C. So how do we do this? We have to rearrange the formula. The way we do this, we're going to rearrange the formula to isolate C, because that's the word we're looking for, not the cos C. Remember, cos C is a ratio. We're looking for C. How do I rearrange the formula? First, take this portion, and we're going to switch teams, change jerseys. And we're also going to take the C squared and switch teams, change jerseys. So what it's going to look like is a positive 2DE cos C equal D squared plus E squared minus C squared. And then to get the cos C by itself, we'll divide both sides by 2DE. And we end up with cos C equal D squared plus E squared minus C squared all over 2DE. But again, remember, cos C is the ratio, right? So we will want cos C, we want C. So C is going to equal the inverse. So we'll say the cos inverse of what, of that right there. So we'll say D squared plus E squared minus C squared over 2DE. That is the rearranging the formula. So again, really all you have to memorize is this one formula. And as long as you know how to rearrange it, you're good to go. Switch out letters, isolate for the angle if need be. So anyway, if we type in our calculator, we're going to use our calculator here. We're looking for cos -1, or cos inverse of, and D squared is really 8 squared plus E squared, which is really 10 squared, minus C squared, which is 9 squared, all over 2 times 8 times 10, close bracket. If you do GDC work, if you're really good with your GDC, you can actually type that all in one shot. But you're probably going to want to put brackets around the numerator and then around the denominator when you're doing that, if you know how to use brackets properly. So go ahead and try that. You can pause the video, and you should get C is about 59 degrees if you round to the nearest degree. Okay, if you don't get that, you likely used the calculator incorrectly. So now we know that this angle in here is 59 degrees, which means the opposite angle is also 59 degrees. And now we can use the sine law. I know sine of A over A is going to equal to sine of B over B equal to sine of C over C. And we know that sine 59 over X is equal to sine 72 over 6. If we cross multiply, I get 6 sine 59. We get rid of that cursor. We get 6 sine 59 equal X sine 72. So X will equal 6 sine 59 divided by sine 72. And I called it X. It's really technically side length C, but we're going to get X equal about 5.4 meters if you do that correctly, rounded to the nearest tenth. All right. Hope that video helps you guys. God bless. Please check out the homework associated with 8.2 day 1.